Hello students, welcome back to the another session of our data structure journey. Last video we are completed what is a binary tree, what are the different type of binary tree. Today we are going to learn how to implement the binary tree using the C language. So practical implementation we have to go right now. So what is a binary tree? Binary tree which have maximum two children. It means each node can have 0, 1 or 2. More than 2 is not allowed. So if a node has any children, then it can be a maximum it can be 0 or at most it can be 2 children. More than that it's not allowed. So let us take an example. This is the binary tree because here root is 10. Root node has 2 children. Left right is present 20, 30. So 30 does not have any children, but 20 have two children, 40 and 50. For example, we have to implement this one by help of a C language. So here what happened? If you go for root, this node, so if we want to store this information means we want to store the information about the root information means what is the content of the root, then what is the left child and what is the right child. Two information we required, what is the left child value, what is the right child value. So here minimum three things we require. So how to implement in a C language? So there is a concept that is called as the double linked list, which consists of node and node store the information of data as well as two pointer, it can be front or back. So here what happened, we can represent the tree by help of the double linked list where the node store the information about the parent node as well as the information about the left child as well as the information about the right child. So three things we require. So here in C language we can declare structured tree. So T type structure we are going to declare where we define three element. First one is the data where we are going to store the parent data information, structure node left. So it will store the address of left child. Then structure node star means address of right child. So three information required for the structure declaration in case of C language. So if we want to store this information, this tree in a dynamic memory allocation, then what happened? First, we have to create a node, store the information, and both the pointer, left and right pointer, we have to make as a null because initially we don't know which one is the left child, which one is the right child. And this node address is 100 and information is stored the 10 because in this diagram, our first node store the value of 10, that is the root node. So this node we have to make as a root. And root store the address of first node. What is the address of first node here? Address is 100. So it store the address of 100. Initially, the rule is root is a pointer that points to the structure of tree and initialization with the null value. So whenever we create the root node, this is the root node, then it stores the root node address and point to this one. So this one is completed. Next, we have to create the memory allocation for the to store the 20 information, make the connection. Then what happened? We create another node. We store the information 20 and left pointer as well as the right pointer store the null value. Why? Because right now 20 is the information. We don't know the left child or right child information. We don't have any information, but we only know the data is stored to 20 and its address is 200. Now, if we store this root node left pointer to 200, then what happened? It make connection. So we can say root, this child is this one. So now we store 200. Then what happened? Once you store the 200 address, now this pointer points to this one. So this node is created. Similarly, another node that is the 30. So we create the node 30 and both the pointer right now store the null value and the address is 300. Now here if we store the 300, then what happened? This pointer points to this node. Now we store the 300. If you 300 means now this pointer points to 300. Now this is the root, this is the left child, right child, both the child information we store. Now 30. 30 does not have any children. So only 20 have two children, that the 40 and 50. So again we have to, for example, we want to store the 40. So we have to create the address for the memory allocation 40, address is 400, data is 40, both the pointer store the null value, and we have to make a connection. So how to make a connection? Left pointer store this address and make the connection. The same way we have to do in the programming point of view. You have to create a node, store the information, make the both pointer as a null. Then you make a parent to the left child or right child, make the connection. Then only the tree connection is established. So next value is 50. So next value 50 means, so new memory allocation is done. So first what happened, the memory allocation for the 50 value is created, node created with the address is 500 address. Now this one we have to make to the make a right child of this node. So right child of this node means if we store the 500 here, then only make it can become the right child of this node. So we store the 500 value, then the connection is established. So this is the way we can implement the binary tree by help of the double linked list. Why double linked list? Because it has both side link possible, and binary tree only two children, maximum two children is allowed. That's why we have to use the double linked list for the binary tree implementation in a C language. So next we have to go for the implementation in C language. Structured tree. So it has three information: integer, data, then tree, pointer, left pointer, then tree, another pointer, that is the tree type pointer, that is the right. So this is our tree structure declaration is over. So first we have to initialization, that is the root as a null value. So we make a tree. So we make the pointer name as a root and store the value of null. Now here what happened, whenever we go for the any node, first we have to create the node and store the information. So now we are going to define a function name as the create. It takes a one integer value, create the node and only return the address of this node. So address of this node means return value is pointer of a tree type. Then the function name is the create. It takes the num value. So now what happened? First we have to allocate the memory. So for example, the pointer is we are using, that is the ptr. Then the malloc is the function which is used for the memory allocation for the tree. Here we are use the size of operator because we don't know what the structure, how much memory is required. For that we use the size of operator to calculate how much memory is required. According to that, the memory allocation is done. Next, then what happened? We have to check whether memory allocation done or not. So for that, if we go for if ptr equal to null, if ptr equal to null, then you make the printf, new line, memory allocation is not done. Memory allocation is not done. Else means memory allocation is done. Once the memory allocation is done, then what happened? We have to store the data value. What is the data value? Whatever the num we pass. Then we make the ptr left pointer as well as ptr right pointer. Means left child as well as the right child we make as a null. After that, we have to return which value? Return the ptr, because this function returns which value? Ptr value. So our create function is over. Once create function is over, then we have to go to the main function. So main function void main. So here we have just write down that it is a pre-implementation binary pre-implementation using doubly linked. It is our choice what we want our output screen should be displayed. It is not mandatory this thing we have to do. It is purely customer or user choice. So whatever you want, you can write down here. Once we print, then what happened? So here we have to create. So for example, we want to store the information of the root node as a 10 value. So we can write down root equal to create function and we pass which value, because here we have to pass the some numeric value. So we store the 10 value. Then we want to print the value. Printf new line. Printf new line. Root equal to %d. Then where the information store in the data. So we have to access this one. After that, we can go for get ch. Then we also can go for before the main start, we can make clear screen also. So let us compile the program. Then we have to go to the run the program. Binary tree root value. So we create the node, store the value of root as a 10. Okay. Now, one by one we have to do. So then now we create the node. Next one, we want that we should store which value? Left child is 20. So what we have to make the root left pointer store which value? That is the create 20. Let us modify the program as per the output screen. So now we have to compile this one, then we have to go for out. So now this is the 10 is our root node. After the 10 node, what happened? 20 is the 20 and 32 children. After that, 20, 30, 22 children, that is the 40, 50s. So this is the way we create a binary tree as well as we store the data as well as we print the data as per the tree format. Let us understand how the program is executed. So as we know, control start is execution from the main method. So it's clear the screen implementation of tree using the double linked list. Then what happened? Create 10 will be create 10. So what happened? Control go to this position and num store which value? 10 value. So PTR. For example, this is our PTR is a tree memory allocation is done. It is 100. If it is 100 means if PTR equal to null, no, it will go to else part PTR data. So this is the data part store which value? Num value. What is the num? Num is 10. So it store the value of 10. So now this store which value? Num. This is null value. So this is the null value. This is also null value. Both pointer points to the null value. So this is the, and what it's written? It returns the starting address. Starting address of this memory allocation, that is the 100, because what the function is return tree node, so it returns the PTR value. What is the PTR value? 100. So now root store which value? PTR. So now this is the root. Now root point to this one. So next line is executed after that. Root left. So whatever the create function will be returned, it will store in which value? That is the root left. So now in this case, what happened? We pass which value? 20 value. So whenever we pass the 20 value at that time, what happened? It will be go to the which function? That is the create function. Now create function which value we are using? 20 value we pass. So it will store which value? 20. Next line, PTR memory allocation. For example, memory allocation we try to execute. So what happened is memory allocation is done. So memory allocation this one. So this memory allocation is done. For example, address is 200. PTR equal to null, no. Else part PTR data store the num value. Which value? That is the 20 value store. So it stores the 20 value. Then PTR left and equal to PTR right equal to null. Both are we make as a null. So make the null. Return which value? PTR value. What is the PTR? PTR is 100. So it returns value to 200. So 200 store which value? Root left. What is root? 100. 100 left which value? This value. So what happened? Now it connects to this node. Then what happened? After that, what happened? The next line will be executed. What is the next line? So this line is already executed. Now the next line means create 30 will be executed. So whenever it create 30 means it stores which value? Num store the 30 value. Now PTR, for example, the PTR memory allocation is done and address is 300. For example, PTR equal to null? No. Then PTR data store which value? This value. So it store which value? Now we store the 30 value. PTR left equal to PTR right equal to null. So here what happened? Both the pointer points to this one. Then return PTR. So what it will return? This is the PTR. PTR value what? 300. So it will 300 it returns. 300 store which value? 300 store the root right. What is the root? Root is 100. 100 right this portion. So it store the, so whenever it stores this value, then it points to the. So now one root, left child, right child is created. After that, the next line will be executed. Next line is create 40. So now here what happened? Now 40 store inside the num value. PTR pointer is created. So now PTR pointer is created with the memory allocation, for example, 600. PTR equal to null? No. Else part will be executed. PTR data store which value? 40 value. So it store which value? 40 value. And both the pointer points to the null because PTR left equal to PTR right equal to null. Return PTR. What is the PTR? 600. So whatever it is returns, it store which value? Right now it's return which value? 400. 400 stored root. 100 left. 100 left is 200. 200 left. This position, what we have to store? That is, it is a 600. It value is 600. So you store the 600. Whenever you store the 600, connection established to this node. Then another will be created, that is create 50. Create 50 means here what happened? What is the num value? Num value is the 50. So PTR. So one more tree is created. For example, address is 800. So PTR equal to null? No. Then it will go to the else part. PTR data store which value? Num value. What is the num? 50. What is PTR? 800. So this stores the value of 50. PTR left equal to PTR right. So this is the right. Return PTR. What is the PTR? 800. So it returns value is 800. Store which value? Root left right. Root is 100. Root right is, no sorry, root right, no, this is root left. So this is root 100, left is 200, 200 right is this position. This position store which value? 800. If store the 800 means what happened? Now connection established to this one. So this is the tree or not? What was our tree? This is our tree. 20, 30, then 40, then 50. We created this one or not? So we created. Right now, then what happened? So creation is over. Now we have to print the value. So this is our output screen. So how the output screen will print? New line, root tab, root data. What is the root? 100. Data is 10. Then what happened? Next new line will be created. One tab. After one tab, what is the root left? Root 100. Left is 200. 200 data is 20. So it is stored the which value? 20. Then after that, what happened? Two tab. There is no new line. After that, two tab. Two tab means this position it will reach. Then root right. Root is 100. Right is 300. 300 data is 30. Then new line will be created. So it will go to the next line. Then what happened? Root left. Root is 100. Left is 200. 200 left is 600. 600 left data is 40. Similarly, root left, right, root left 200, right is 800, 800 data is 50. So it will display. So this is the way we got the output screen. So here what happened, it is a small tree. That's why it is easy to construct and print. So, but anyhow, we have to know basic information how to create a node of tree, how to store the data, how to print the data. Hope you are able to understand the concept. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you.